Okay, this is test number 1, problem 1. It says determine the domain for the following functions. F of x equals 2 divided by the cube root of 4 minus x. When we find the domain, we're talking about what values can x equal. And we have a cube root here, and we know that inside this cube root, the number cannot be less than 0. So, let's set this cube root, so cube root of 4 minus x, set it equal to 0, and we'll cube both sides, so we'll have 4 minus x equals 0, and again x equals 4. So this is our illegal value. And it asks for the domain, so we're going to write the domain as everything but that x equals 4. So it's going to be an open parenthesis where negative infinity to 4 and 4 to infinity. And these are all open brackets because our domain x cannot equal 4. Okay, this is problem number B. Again, we're finding the domain. And it says f of x equals ln of x squared minus x minus 6. And we know the trouble spots in our ln's are anything greater than 0 or less than 0. So we're going to set this x squared minus x minus 6 greater than 0. And we can factor this to be x minus 3 times x plus 2 is greater than 0. So x has to be greater than 3, or x has to be less than negative 2. So we know our illegal values are between negative 2 and 3. And our domain will be an open bracket for negative infinity to 2, or open bracket 3 to infinity. Okay, this is problem number 2. It says show the function f of x that equals 4 minus 2x divided by 3x plus 2 is 1 to 1. And when we show a function is 1 to 1, we need to show that if f of a equals f of b, then a has to equal b. So let's first start by setting these equations equal with a and b. So 4 minus 2a divided by 3a plus 2 equals 4 minus 2b divided by 3b plus 2. And we're going to try to show that a equals b. So we're going to cross multiply. We get 3b plus 2 times 4 minus 2a equals 4 minus 2b times 3a plus 2. And we're going to FOIL both sides, so we get 12b plus 8 minus 6ab minus 4a. That'll equal 12a minus 6ab plus 8 minus 4b. We're going to see if we can get rid of anything on both sides. We have a plus 8, so we can subtract 8 from both sides, and those two will cancel. And we can add a 6ab to both sides, and these two will cancel. So what's left is 12b minus 4a equals 12a minus 4b. So if we group like terms on the same side, we'll move this 4b to the left. So we add 4b to both sides. And then we're going to move the a terms to the right, so we're going to add 4a to the left and 4a to the right. So we have 16b equals 16a. And dividing by 16 on both sides, we get b equals a, which is what we needed to get to show this function is 1 to 1. Okay, this is problem number 3. It says the graph below is the graph of a one-to-one function f of x. On the second axis, sketch the graph of f inverse of x. The sketch of the graph is dotted on the second axis as a reference. So when we sketch the inverse, we're going to mirror this function across the line y equals x. And I'm going to dot that in here for you. So this is the line y equals x. And when we mirror it against here, we'll get something that looks like this. Let's try that one more time. Clear this up. Alright, so let's draw the axis one more time. I'm sorry, the y equals x. Our line we're going to reference. And it should look something like that. Okay, this is problem number 4. It says show the function f of x equals x cubed minus x squared minus x minus 2 is not 1-to-1. You may not use the graph to answer this question. So when we're talking about functions being 1-to-1, we know that for every y, there has to be only one x. So we're going to try to prove that it's not 1-to-1. So let's say x is 0. So f of x, or f of 0, equals negative 2. So x cubed minus x squared minus x minus 2 equals negative 2. And if we add 2 to both sides, we get x cubed minus x squared minus x equals 0. And we can pull out an x. So x times x squared minus x minus 1 equals 0. And now we can set both of these equal to 0. We already know that x equals 0 for this function. But x squared minus x minus 1 also equals 0. And if we use the quadratic, we get x equals plus or minus, 1 plus or minus the square root of 1 minus 4 times 1 times negative 1 all over 2. And this will simplify to be 1 plus or minus the square root of 5 all over 2. So we know that f of 0 equals negative 2. F of 1 plus root 5 divided by 2 equals negative 2. And f of 1 minus root 5 divided by 2 equals negative 2. So this function is not 1-to-1. Another way to go about showing and doing this problem is choosing two different x values that give you the same y value. So let's try, let's choose 1 and negative 1. So f of 1 equals 1 cubed, which is 1, minus 1 squared, which is 1, minus 1 minus 2, and this equals negative 3. And f of negative 1 is negative 1 cubed minus negative 1 squared minus negative 1 minus 2. This is negative 1 minus, negative 1 squared is positive 1, so minus 1, plus 1 minus 2, which is also negative 3. So we showed that two different x values equal the same value, which also shows that it's not 1-to-1. So these are two different ways you could go about doing this problem. Okay, this is problem number 5. It says assume the function f of x equals 2 divided by the cube root of 4 minus x is not 1-to-1, or is 1-to-1, on the domain negative infinity to 0. Determine the function f inverse of x. When we find the function, the inverse of a function, we switch x and y, and then we solve for y. So we have y equals 2 divided by the cube root of 4 minus x. So the first thing we need to do is switch the x and the y. So x equals 2 divided by the cube root of 4 minus x. And now we're going to, 4 minus y. We need to switch the x and the y. So 4 minus y. And now we need to solve for y. So let's multiply this cube root of 4 minus y to the other side. So we have the cube root of 4 minus y times the x equals 2. And then divide the x back over, so we'll have the cube root of 4 minus y equals 2 divided by x. Let's cube both sides to get rid of the cube root. So we'll cube the left and the right. So we're left with 4 minus y on the left equals, make sure the cube goes to the 2 and to the x. So 2 cubed is 8 divided by x cubed. And we need to subtract the 4 from both sides. So we have negative y equals 8 over x cubed minus 4, and then divide through by a negative 1. So we have y equals negative 8 over x cubed plus 4. This is our F inverse. Okay, this is problem number 6. It says solve the following equation. So this is A, log base 3 of 2x squared minus 5x equals 1. So the rule we're going to use to solve for x is the a to the log base a of x equals x. So if we raise both sides, if we use 3 as a base, this will be 3 to the log base 3 of 2x squared minus 5x equals 3 to the first. Based on this rule, we know that this inside will drop down. So we have 2x squared minus 5x equals 3. And let's subtract the 3 over. So we have 2x squared minus 5x minus 3 equals 0. And using the quadratic, we find that x equals 5 plus or minus the square root of 25 minus 4 times 2 and then times negative 3, all divided by 4. And that's 5 plus or minus square root of 49 divided by 4, or 5 plus or minus 7 divided by 4, which is either 12 or negative 2. And that's 3 or negative 1/2. Now since this is a log function, we need to go back and check before we can circle our answers. So let's check our solutions. We have x is 3, so plugging 3 in, we get 2 times 3 squared minus 5 times 3. That equals 18 minus 15, and that's greater than 0. So 3 is a solution. Now let's plug in negative 1/2. We have 2 times negative 1/2 squared minus 5 times negative 1/2. That equals 2/4 plus 5/2, which is greater than 0. So negative 1/2 is also a solution. So x equals 3, or x equals negative 1/2. Okay, this is problem number B. It says we need to solve again. This is 8 to the 2x times 1/4 to the x minus 2 equals 2 to the negative x minus 2. So what we can do is get all common bases and 2 is going to be a good common base to use. So if we rewrite 8, we want it to be with base 2, so we need it to be 2 cubed. That equals 8, and we still have the 2x with it. And that's times 1/4. 1/4 can be written with a base 2 as 2 to the negative 2. And we still have that x minus 2 on top. And that equals, we already have a base 2 with the exponent on the right, so we keep everything the same. And now let's simplify a little bit. We have 2 to the 3 times 2x, so we have 2 to the 6x times 2 to the negative 2x plus 4 equals 2 to the negative x minus 2. And when you multiply the exponents on the left, we have to add them. So combining, we have 2 to the 6x plus a negative 2x plus 4 equals 2 to the negative x minus 2. And 6x minus 2x is 4x plus 4 equals 2 to the negative x minus 2. So now that we have just one term on the left and one term on the right with the same base, we can set the exponents equal. So 4x plus 4 has to equal negative x minus 2. And getting like terms on both on the same side, we'll add an x to the right. So we have 5x on the left plus 4 equals negative 2. And we'll subtract the 4 on the left. So we have 5x equals negative 6. So x equals negative 6/5.